And we start to exceed those limits that are like unnatural, to 6'3" to a 5'4".
We always get sidetracked with these questions. Connor, what's your major?
GIS.
You should go into one of like the kinesiology. All right, so I'm going to go through this step by step. So here's just how to. This is the formula. In this case, for the difference of means, you're going to use the t-statistic. And really, these are ingredients. When I look at formulas, I'm like, what do I have to plug in? So I need the sample mean for the unrestricted, sample mean for the standard deviation, or for the sleep deprived, and I need their standard deviations, and I have the square root, I need the n1s and n2s. So the ingredients I need is I first need to start with this thing. And the biggest problem with these things are just, it's called bookkeeping. I'm always surprised when someone likes these kind of formula crunching classes, because to me they were never interesting. I'm just plugging things in, and I don't really care. But it's about bookkeeping, which, as you know, I'm not good at. So I think up to my third year of courses in undergrad, a professor would have been surprised to think that I could have got a PhD in math. Because all those classes are about bookkeeping. 104, bookkeeping. Not good at it. This is like not remarkable, it's not terrible. I just didn't hit the radar.
You grew the haters wrong.
Huh?
You grew the haters wrong.
Not a hater, it's like you look at your class and your professors know you from class. They don't know you outside of class too much, right? So they don't know how you're thinking outside of class. And then one of the professors I had, I went back to do research with him, and he said, oh, sure, I'll sign up to be your mentor. And then they came back with the research stuff, and he's like, oh, this is actually really good. He was surprised. But that's like, I'm driven by curiosity. I'm not driven by crunching formulas and bookkeeping. So that's why I was good at one thing and not the other.
Be like that.
All right, so this is the formula. You can't have a reference sheet, but you can tab it in your book that this is the formula for comparison of means. That's what I would label it as. Theory-based comparison of means, so you can find it easily. Does everybody have that copied?
No.
Why does the 0 need to be at the end of it?
Because it's supposed to, the difference of means may, this is the null hypothesis thing. I'm actually going to give you arrows to tell you what each thing is.
Okay.
But so if the difference of means doesn't necessarily have to be 0 in the null hypothesis. For our case, it is. I think for everything you do, it is 0. Got it? I think it's on the next page too. So this is the hypothesized mean for the null distribution, the null hypothesis. This is the standard deviation from the samples. I've got them all labeled in here. That's what all those things are. This would be actually a good class for a formula reference, like making your own cheat sheet for it, because there's not much here, but it's a lot to remember all at once. And there's some validity conditions. I'm going to go through that with you too, like how to do it. Well, in the R code, folding it right into the R code. Got it? Down?
No, I just wrote the name of it. I'm just going to tab in the book.
No, that's not how you learn best.
Oh.
So I'll tell you, like when I first started doing this, I stopped having students take notes, and then I read in the literature that you do better when you take notes.
No, I wrote everything down. The name of that's right there.
Yeah, then they're just gibberish.
Yeah.
It doesn't mean, they don't mean anything. Okay, so here again, so I'm not erasing anything. And so this first step is to compute the difference in means. I just went to the problem that we had in the book. These are actually book problems. I don't know if you have the solutions in the book, but I just cranked out all the ingredients that I need to plug in here. The first step is difference of means, and it turns out to be 15.92. And my point disappeared. It's supposed to be 15.92. And so this is how I'm doing it. So that 15.92 just goes right there.
And Is this what we do or the other class does?
This is all the other classes doing.
Oh, okay.
They don't.
So why are we, I have a question, so why are we looking at this?
Because if you finish a stat class, so I think if Colonel Kaminsky had his own way, he might just not ever do this. Because it doesn't tell you anything. Like, you don't really know what you're doing when you're plugging all these things in. But the reason we're doing this, if you finish a stat class, most people wouldn't think that you did this.
Oh, okay.
So when Colonel Kaminsky wanted to have this class, that was the first thing, like, what? You're not going to have this? And then probability, which they're filling in at the end. Okay, second step is to compute these guys down here, the standard deviations. And as far as I know, you have no way to do this except in R, or the applets, which I'm against right now. But in my describe command, it spits you out those standard deviations. We did it the other day, actually. So those two numbers go in here. And then these are the sample sizes. So one was 11 and one was 10. So those go in for N1 and N2. And then you compute everything. I'm going to show you how I did that because I'm you know from my grading stuff that I'm not a bookkeeper. You're allowed to use Excel on your test. So if you have a bookkeeping problem, put everything in an Excel file. So N1 was 10, N2 was 11. I needed these guys squared in the formula, so I took the standard deviation, which I cranked from the describe command, punched it in here. This is the sleep-deprived group, the standard deviation squared. And then I did the first fraction that was in the denominator, the second fraction. The denominator is the square root of both of those. That way I don't make a mistake on my calculator. It's all there. So I have it in pieces. That's how I do it. I do it because I know that I was talking about inoculating yourself against you. I'm inoculating myself against me. I know that I make little mistakes everywhere, so this prevents me from making that if I just put it all into an Excel file. Even with all this, I used to do this in college, still I was a B plus A minus at best. So there's some do this always get 100. Wasn't me. All right, so that was how that works. I have all the numbers cranked out here, but I just pulled them from my Excel file. So I'm just going through my Excel file. This is my denominator, Excel, so I don't make a mistake. And so I'm just pointing to where everything goes. So this number goes in this entire denominator. And then you put it all together. Once you have all those numbers in, you just crunch it out. And if you recall, there was a table back where you had, if it's over 2, there's strong evidence to reject the null. It's over 2. So this comparison of mean method works to tell you that there is a difference between the two groups. The previous one? You can see if somebody doesn't like formulas, this is not going to be a fun class. And if that's all we were doing. And if you have a roommate in the 206 class, they have a book by, I think, what's the guy's name? I forgot the name of the book. But you can look in there, it's all these kind of formulas.
Is it ZIL?
That's it. That's how you do it. How about cranking out the 95% confidence interval? Because that's got the noise in it. Same thing. It's a formula. They use 2 as a multiplier. I wrote it out separately after seeing your homework. There's a plus and a minus. And you just plug in everything. which I already had on my Excel spreadsheet. And once you plug in everything, it cranks you out the answer. And the takeaway for the 95% confidence interval is that 0 is not in there. So believe it or not, when doctors or physicians ask your weight, anything self-reported is unreliable because people are telling you what they want you to think or what they believe is true. None of it really is ground truth. So they really should be weighing me on a scale. But even if they ask me that number, what am I supposed to give them? This is an interval. Since 0 is not in there, it tells, like, let's suppose I give them away, I'm 119 pounds. Well, maybe my confidence interval doesn't have 119 in there. That means that I'm fibbing, right? Here, the null hypothesis is not in here. So that tells me that, again, with a 95% confidence interval, I already know to reject the null. Good?